third presentation in the Francqui Chair lecture series by Professor Jean Vanderdonckt on gestural interaction. I mean, we even had some confusion because it's the third presentation, but the second lecture, because we had the inaugural lecture first, of course. Unfortunately, we were interrupted last year, I think almost a year ago. And I think at that time we thought, oh, okay, in a few weeks, or let's say a maximum a few months, it will be over. And then after the summer, we can just continue with the physical series. But unfortunately, we had to learn that this thing takes a bit longer. So that's why we also decided now to give the last 3 lectures in an online format and also record it so that everybody can later also join the interesting presentations by Jean. Now for today, for the presentation itself, I would ask everybody to mute their microphone during the presentation. But if you have then a question, I just agreed with Jean that he would like to take your questions during the presentation. So I would recommend that you can raise your hand. And then Jean is checking from time to time whether there are any questions, and you could then enable your microphone and have your question hopefully addressed by Jean. Maybe also to mention, we will record the lecture. We will also have the slides, and we plan to make both of these somehow available on the website where everything was announced. I will later also post the link again here in the chat. So that means later you can access the recordings as well as have access to the slides, which I think can be quite handy. And just before maybe Jean starts, of course, we would like to thank also the Francqui Foundation again for supporting this interesting event. So the word is yours, Jean. We are looking forward to an interesting lecture today.
Okay, thank you very much for your introduction, Bert. And as you said, please feel free to stop me at any time. If you have any comment, question, it's better to do it always in context than maybe waiting for the end of the slides and then we forgot about what we said, especially myself. Okay, thank you very much for joining. I will now start with a few questions, maybe in order to initiate the discussion. This is not the one that I wanted. Again, I'm switching from different one. Let me see. I have several screens, and then I have, of course, to find out the right one. I think this is the right one now. Okay. So as a very first, let's say, a very first question, let's imagine that I want to, in my presentation, since I'm using PowerPoint, I would like to move from the current slide to the next slide, right? So if I'm using a mouse, what would you do? You can take your microphone, of course. Huh?
You would click the mouse.
Yes, but click on which button?
Left one.
Ah, this is strange because you click on the left button to go to the next slide, which is usually on the right.
Yeah.
Okay, right. Click on the left button. If you're using the Apple Magic Mouse, since there is no button or no separate button, what do? But you click on the whole surface because there is no choice, no other choice. Okay, if I'm using the keyboard, so here I have several options. Maybe I can press the space bar or the right arrow, or maybe page down. They're all equivalent. Okay, that's for going to the next slide. Now, if I have to go back to the previous slide, let's say now I have to do that. If I'm using a mouse, should I click on the right button in order to go left, which is always strange, or something else? Yes, I can click on the right button, but it makes a menu appearing, thus making it disturbing. So this introduces again a very first disruption in my presentation. If I'm using again the Apple Magic Mouse, well, I can hold down the Control key and then click whatever I want, but this is again very strange. or I can go to System Preferences and I can enable a secondary click so as to say, for instance, if I double click or if I click on a certain area, then it goes to the previous slide. So in this case, I can personalize my user interface, or my mouse in this case. But if I'm not using any mouse or any keyboard, of course, I can use any remote control, like those one, like the one from Apple TV, or remote control from various devices and companies and brands, like from Logitech or Targus. Or I can use also a remote control with USB port. But again, I don't like to have anything in hand. Since I'm interacting, I would like perhaps to interact with gesture. So I would like to do it without any dedicated device in hand. Because if I have a device in my hands, I will be busy with it. So for instance, I'd like to do a gesture like swipe right will go to the next slide, and swipe left with my hand, maybe like this or like that, would go back to the previous slide. Okay, that would be nice. But what can I do if I don't want to hold any device in my hand? So, of course, I can equip my computer with maybe a Microsoft Kinect or a Leap Motion controller. But again, I am forced to remain in a certain area called detection cone, in which the gesture will be captured by the Microsoft Kinect or by the Leap Motion controller. The nice thing is that I don't have any device anymore in my hands, but still I am forced to stay in front of my computer. So now, what do you think? Can I do the same, like going to the next slide without any device and without being constrained by the position? So only by some gesture in space and without any magic. Any idea? How can I do that?
Maybe a wearable like a bracelet or a ring.
Yeah.
Of course, it is still a device, but you're not feeling it like a device, so you just wear it actually.
I was thinking about a mayo, the one that you put on your arm.
That's right. Of course, I can use some magic stuff like the magic wand, which is a real device equipped with already 13 gestures, which can serve for remote control. So I can, of course, move the magic wand around, and not because I'm not Harry Potter, but I can do that. Unfortunately, I cannot personalize the gesture with this device. I cannot add any more gesture, or I cannot personalize or customize my gesture. So I can use this one, but I still have something in my hand. So if I don't want, then
you can use a glove.
Yes, that's right. I can use a glove, but then I still have something more or less intrusive, more or less. So in this case, of course, what would be nice is to have, like Audrey said, I can use maybe an armband. So let me share the other screen again. Okay, so this is the magic wand that I've shown you in a minute. It's a real device. It's not just for magic, so you can really use it, like for playing music, for remote control of your iPhone or your media player, or learning some code. Like for instance, if you draw, let's say 1, 2, 3 in space, then 1, 2, 3 can be attached to some operation, but that's all. And I don't think that this type of gesture is very natural. If I have to draw with a magic hand 1, 2, 3, and this will display something, I'm not sure that this gesture is very natural. So another one that is, of course, very nice is the Mio armband that was just mentioned by Audrey a few minutes ago. And so this is this one. Can you hear the sound? Just checking.
It's very low, so it's.
Yes.
I cannot hear it very well.
I don't know why. I'm 100. Okay, anyway, with the armband, this device is, of course, I don't have anything in my hand, but still I have to wear some device. So this is not perfectly non-intrusive, but at least it leaves me some of my degrees of freedom. So this is, of course, different than from other types of devices like the Wiimote or whatever, and it's relying on the contraction and decontraction of my muscles. So the device is nice. I will not go further for this device. The device is nice, but the problem is that do we have the right gesture with this device? The problem with this device is that it is equipped when I can sell it, I can buy it. It is already equipped with a series of gestures that are predefined. So in general, what we said before is, of course, gestural interaction is suitable for some cases, and for some others it is not at all suitable. It's not good enough for anything. Usually we say that gestural interaction is good when we need to interact with physical objects in a way that tries to replicate its physical functioning, or when it is very flexible with hardware, or also for fun, like in games. But we have also to keep in mind that gestural interaction is not suitable at all for data input. For instance, if I want to write something, of course I can make a gesture in the air like that, but this is not very practical, and it's very tiring after a few minutes. We also know that gesture suffers heavily from a lack of visual feedback, because if I'm gesturing even in the air and I'm making some gestures, the only thing I can see is whether the system will recognize my gesture, yes or no. So this is not very good. Let me see if I can. Again, I have to switch to the other one. I'm sorry. Switching all of these windows. Okay. Gesture interaction is perhaps attractive for several reasons, but it's not always natural. So, for instance, if I'm using a gesture user interface, I should not, in principle, design it just for the sake of it. The goal is not to produce a gesture interface per se, but maybe to improve an existing interface by gesture. So here is an example taken from a local restaurant located in Louvain-la-Neuve called the Wokey Restaurant. So when I'm entering this restaurant, well, of course, for the moment it's closed, but when I'm entering this restaurant for Asian food, it's a point and click user interface. So of course I can point to all the things that I want in my plate, like onions, vegetables, meat, sauce, etc. And then I have to click next to add some more parts to that. And then next, and then click and click and click again. The problem is that if, for instance, I'm selecting too much sauce, which I should not, of course, if I'm selecting 3 portions of sauce, then the system tells me is not possible unless I remove some other, maybe vegetables or whatever. So I have to go back, then click back, 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 remove 1 portion of vegetables, and then forward, 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 and then I can add another sauce. Same for the meat. If, for instance, I would like to have more rice or more meat, I have to navigate through all screens in order to select or unselect the portion that I want. So even if it is a point and click user interface, which is very easy to manipulate in principle, we have always to flip among these windows, and I have always to understand the constraints. is that when I have reached a maximum amount of meat, I cannot add any more. So what we did is we took the same interface with the same functions and we presented all the ingredients into one screen, as you can see here on the right, and people were allowed to produce some gestures like put this meat in this pan, or I don't want rice, I want 1 portion of vegetables, I want 3 portions of this. And while the system recognizes these gestures, it says, yes, you can do it, or no, you can't do it. So in this case, there was only one screen, no more any need for several screens, only one screen, and everything was made by gestures only on one screen at a time. So when we interviewed some people to try, not in the restaurant because that was not allowed, we compared with some people outside. Usually people prefer that, although they were a little bit confused by the fact that they could write with their finger 3 on top of the screen, or 1, or not this one, or move this down. They were a little bit confused by the gesture because they didn't expect a system to behave like this. And when we presented that to the Wokey restaurant, they said, oh, it is just too complex. We cannot replace a very good system by another one. And then we said, yes, but we proved that it's better than the graphical user interface. Yes, but you know it's too complicated to replace an existing system with this one. So that's life. So the main problems that we have with gestural user interfaces is that usually the operating system imposes an already existing set of gestures. When these gestures are natural, that's fine. I'm happy with them. But if they are not natural, or if these gestures are not the gestures expected by end user, then they will be rejected. A second problem is that usually the gestures, or well, maybe not usually, but sometimes gestures may suffer from a lack of acceptability, especially social acceptability. If I am moving my hand around in front of a screen, maybe in a street or in a shop or even in class, some people consider it not socially acceptable, or they don't want to do that because they are afraid to be seen like this, agitating their hands and their arms in front of a screen to manipulate some contents. A second drawback is the lack of consensus, is that a gesture which could be accepted or welcomed by one person could be rejected by another one. So this is why we have to say that there is a difference between so-called system-defined gestures as opposed to designer-defined, user-defined, or hybrid, which is a combination. Let me give you this example. This device that you can see on the screen is a so-called 3D touchpad. It's a very nice device which enables me to recognize 2 types of touch gestures, like this one, it's a multi-finger one, or a surface gesture on the edge, and 5 mid-air gestures that can be produced in 3D, like drawing a clockwise circle on top of the pad, or flipping my hands, or moving my hand up and down. So these are 7 so-called predefined, designer-defined gestures. So the design of this device commercialized these 7 gestures, but these are designer-defined gestures. So let me show you how this device works anyway. Again, flipping on. Where is it? Okay. So this is the touchpad, how it works. So this touchpad is a tiny device. Is a little bit larger than a usual trackpad on your laptop, and it is in standard equipped with these gestures that can be recognized by the device. Because these gestures were suggested by designers. But if I want another one, or if I disagree with these gestures, I have to develop or to program everything by myself. So this is the device. As you can see, it's very nice for a single or multiple touch, or even with several fingers. It can be used for scrolling up and down, or also with the edge. So it really exploits very well the capabilities of this device. And on top of that, we can also produce some mid-air gestures without actually touching the device, like swiping right, left, drawing a clockwise circle or a counterclockwise. And this is very nice in order to be used with different applications. Like here is a very simple game. If I want to orient the penguin, I just need to move the hands accordingly. So this is very practical because the physical movement is isometric to the hand movement. This is for previous slide. So in this way, this is at least natural. Or next slide. So we can combine touch-based gestures with 3D gestures, like for copy-paste. And it could also be used for continuous gesture, like for increasing the volume of my media player. So this device is very nice, but the problem is that, the problem or the limitation is that it is shipped with these 7 gestures. So if I'm happy with them, that's fine. But if I want to change them, or if I want to add new gestures, or if I just want to customize, I can't do this with the software development toolkit. I have to do everything by hand. So in this case, I have to capture the signal. Like as you can see here, this tracking application shows the position of the hand in space. And the bars on the left indicates the elevation. So of course I have this application in order to capture the gesture, but it doesn't help me to recognize these gestures. So these are so-called designer-defined gestures, right? And when we perform some elicitation from people, so from 30 different people, we gather a lot more gestures, as you can see here in this list. Of course, there were some gestures that were already recognized, but some others were not recognized. So just by asking people which gesture would you like to have for this or that operation, which is an elicitation, we gathered a list of 26 different gestures. So much more than what we have in this device. Another example is that although I'm a fan of Apple's iOS, iOS is shipped with 7 so-called system-defined gestures, which you can see here again in this application. So I have to switch again. Sorry about all of this switching, but there are just too many screens. Okay, so one interesting site is called GestureCons, where you have a graphical image of all gestures supported, all system-defined gestures supported by operating systems. So if I'm clicking on iOS, I only have the list of system-defined gestures like tap, double tap. So triple tap is not supported apparently, unless I do it myself. Of course, I have the pinch in and pinch out, the rotate, the flick in any direction, or the 2-finger drag down or drag up. Again, if I'm using 3 fingers or even more, this is not supported. The nice thing with this GestureCons website is that you can compare different gestures offered by different operating systems. So if I click on Android, I have less gestures. WebOS, I have a little bit more. Windows, I have a little bit more. And of course, if I go to Surface from Microsoft, I have even more gestures. And with the Kinect, I have, of course, full body gestures. So all of these gestures are so-called system-defined gestures, but they are not user-defined. Again, if there is a good mapping between what the user wants and what the system offers, that's fine. But if this is not the case, then gesture might be considered unusable. Okay. So now the question is, if we regret that system-defined gestures may be not usable, and maybe gesture defined by users are better, why is it better? Well, there is a study performed by Nashenta and other colleagues, which says that when the end users define their own gestures, the result is that they remember the gesture that they have produced 20% more than if the gestures were designed by designers. They strongly prefer their own gestures, and even they think that their own gestures will take less time to learn and to produce. So even if the gesture proposed by an end user is a little bit more complex, it is perceived as being easier to produce and to remember. So there is a good empirical validation that user-defined gestures are better than system-defined gestures. So the goal for designing gesture is, of course, to come up with a gesture set that should satisfy several quality properties. Acceptability, I've been already talking about. Consistency, I will come back on that later. But also discriminability. Like, for instance, here is a very old study which compared different shapes. It was done for control rooms. I know that, for instance, Denis Javot is a specialist for user interfaces for control rooms. So in this very old study performed in the US, they compared several shapes and they asked people to what extent can you discriminate these different shapes, and saying that, for instance, you cannot be confused by two shapes which looks like too much similar, like the heptagon is quite close to an hexagon or to an octagon, or even a rectangle can be easily confused with a rectangle with rounded corners or with cut corners. And what they did is that in the end, they identified the best set of discriminable shapes. So we have to do the same for gestures. Of course, when the gestures are proposed by vendors, like from Microsoft or from IBM, some gestures might be considered natural when they are based on some metaphors. Like here, for instance, in this gesture set for pen-based, it is heavily inspired by stenography. Like, for instance, the cut is this gesture, or the paste is replaced by this gesture because it's very familiar in the area of stenography. Again, if I learned in the past stenography, then I may remember this gesture perhaps easily, but unfortunately, at least for myself, I never learned stenography in my life, so I have to keep that in mind. And for me, this gesture, which may be memorable for those people, might be not so easy to remember for me. So in order to come up with user-defined gestures, one possible method, and I will elaborate on that during the next lesson, but not during this one, is to perform a so-called gesture elicitation study. Elicitation comes from the domains of requirements elicitation, where we ask people, what do you like for performing this? Or what type of gesture would you like to do that? Or what type of functionality would you like to have for this system? So people are prompted to give their expectations, needs, preferences in order to incorporate that in the user interface. So elicitation study, of course, I will detail that during the next lesson, but let me give you a small introduction. So the goal is a method for maximizing the guessability. So that, for instance, if I have, let's say, a population of users, which may be the target of people for my application, we want to understand which are the preferences of these people for any action. It could be a command, it could be a vocal command, it could be a gesture, it could be a shortcut, it could be a keyboard or a mouse action. So then we gather some participants and then we ask them, please give me the gesture shortcut for help. So if I say, for instance, what would be the keyboard shortcut for help? Almost today, everybody will answer F1. F1 equals help. But now if I have to ask these people, please give me a gesture for help, what they will come up with different proposals. So we have to collect all of these proposals. And let's say that, for instance, some people will draw a question mark. Some other people will like to make a gesture consisting of drawing a H letter. And in my sample here, I have 15 people suggesting to use H and 5 using a question mark. So what can I do with that? So then we can compute a so-called agreement rate. So I will not explain the formula, but basically it computes how many pairs of people are agreed with each other in order to produce a gesture. So in this case, since I have 15 people out of 20 suggesting a H and 5 of them suggesting a question mark, I have a few pairs of people than for the question mark than for the H. So if I compute the agreement rate, which is the formula, so it's the amount here, then it gives 0.60, which means that more or less, as a percentage, it says that for the most frequently chosen gesture, 60% of all pairs of participants agreed to select a H. Of course, the value can range from 0 to 100, but in practice, it is very infrequent to do that or to see that. We can also compute the disagreement, which is the complementary. Again, I will explain that during the next lesson. So the agreement rate is one possible measure to design a good gesture set, but it's not the only one. So here is an example of a small study that we conducted in order to investigate the viewing position. So, of course, now with smart TVs, I can be in front of my TV, like this person here, and this person is flipping her hand left and right to proceed with the movie, to go forward or fast forward or backward, etc. But the main drawback of that is that the system always assumes that I am sitting or I am in front of my TV, because of course on top of the TV there is a camera capturing my gesture, and if I'm not in the right position, well, but the system will not recognize my gesture. So the system has been completely designed with the fact that I should be in principle in front of my TV and not maybe in my most comfortable position. So what we did is not only we measure the agreement rate, but we ask people to what extent can you memorize or can you recall the gesture that you have proposed? To what extent do you think that it is good or the goodness of it? To what extent do you think that your gesture is good enough for this command? Or to what extent do you think that your gesture is easy to produce or to design, or even if it is fun? So we ask them, please give us your assessment with respect to these measures. And what we found is that actually when people were asked, please take your most favorite and your most comfortable position in a sofa, like you were at home, Well, people are sometimes sitting, like on the bottom right, or they are standing or they are sitting, but maybe more comfortably, or they are lying down here, or they are sitting upright, or maybe half and half. And then depending on the position, or the viewing position, people propose different gestures. So if my viewing position is again in front, like standing in front of the TV, my gesture will be usable. But if I'm sitting down, or if I'm laying down like in the top right position here, maybe I will not produce the same gesture, or it will be very difficult for me to produce the same gesture because the left hand is already pushing on the sofa and the right hand is not very flexible. So the viewing position has a deep impact on the gesture. And again, when we gathered all of this data, we see that some gestures are estimated as comfortable and some others are not at all. Then in the end, when we considered the different gestures, not only we computed the agreement rate, but also we computed a formula trying to incorporate also the other measures like the fun. For instance, the yellow part is the fun aspect. And do you think that your gestures is funny? Or is it enjoyable? Or do you like to produce this gesture because it's a little bit funny? Or not? Or is it boring? So in the end, we came up with this gesture set that maximize not only the agreement rate, but also some other measures like fun and easiness of production. So for instance, in order to say yes or no, not surprisingly, thumb up and thumb down. But in order to open a menu, then pointing index or draw a spiral. For volume up and down, still the palm up and down with the hand was the most agreed gesture, but also the easiest to produce. So by combining different measures, we came up with a gesture set that was expected to be more acceptable, more enjoyable. Unfortunately, with respect to the initial gestures that were designed for a normal viewing position, the agreement rates were lower, surprisingly. Why? Because participants were forced to use their weaker hand, maybe not the dominant hand, because the dominant hand was already busy or was in another position. This I will skip for a minute. Another source of measure is, in this case, we would like to consider the user interface sketching. So in the past, we developed several applications for helping people to sketch a user interface on screen instead of drawing it. Everybody can sketch. You can sketch here, as you can see on this display. You can sketch on a graphic tablet with a stylus. This is very easy. It's straightforward, and it is a quick and dirty approach because I can easily sketch and erase. So we ask people, which representation would you like to have for depicting a widget? So for instance, we ask them, which gesture or which drawing, which representation would you suggest to represent text? So some people proposed a rag line, some others proposed a fuzzy line, some others suggested a straight line. For text field, the three most frequent representation were those three ones here. I can maybe highlight them. So these are the three most frequently suggested representation of a text field. And what is nice is that when it is a text area, so instead of having one line in the rectangle, people suggested to have 2 lines or more so that they can be easily associated. If it is a push button, then they said it should be one rectangle included into another. The search button or the search field would be a looking glass inside a rectangle, and so forth. For instance, the radio button was suggested to be represented as a small circle and then a straight line or a rag line. And then we gathered all of this representation by asking people which representation would you like. And then we came up with a vocabulary of gestures, which are, yes, more or less here. And with these gestures, we incorporated them in the gesture recognition system of the applications in order to be recognized. So there is even a collaborative version, so this called Gambit. So if you want to try, you can go to this app as Spot, and you can try by sketching yourself. So here is an example of a typical session where you have on the left, you have different people who are gathering in a meeting room. This guy here came with a smartphone, so he drew something very small on his smartphone. The other one was using a large tablet. This third guy here in the meeting used his own tablet, and all of these sketches were automatically propagated to the wall screen here so that everybody can see what the others are sketching while they are sketching. So this is a screenshot here on the right. So when people were sketching, first they can sketch freely, so without any recognition, and when they are happy, they can launch the recognition in order to translate these drawings into real code like HTML or use XML code. So this works by using grammar. So here is a little bit how it works behind the curtains. So a list box is described by this representation. So it means we have in the grammar, we have a rectangle first. Then inside the rectangle, we have two triangles, one triangle oriented to the top and the other one to the bottom. So for each of such representations, so some people prefer this representation, some others prefer that representation, or even with some lines inside. So all of these representations were coded in XML so as to be automatically recognized. So even if let's say one user would like to have this bottom right representation here, but instead of using 2 lines, maybe this person would like to have 3 lines or even some, let's say some circle inside, we need to change only the constraint saying that one circle could be included in the rectangle. So here is the corresponding grammar, and this grammar is parsed so as to recognize the corresponding sketch. So here is an example of the various sketches that we gathered and which are now automatically recognized in the system. And in the end, we computed also the recognition rate of these different representations. And what happened is that, of course, even if people are suggesting different representation, like let's say, for instance, a checkbox like here is just a square, or a square with a line, or a square, well, it is supposed to be a square with a letter. Those 3 representations here can be recognized, but with different recognition rates. So here, for instance, for a checkbox, the first one is almost 100% recognized. The second one, not so much. And the last one is recognized only in 88% of cases. So in the end, we can say that from a system point of view, the recognition rate is something. But on the end user point of view, the representation is another side. So these are 2 sides of the coin. For the end user, maybe these are the best representations, but for the system, some of these representations can be recognized effectively and efficiently, and some others cannot be so much well recognized. And in the end, we came up with the best representation, which combines both the acceptability from the end user and also the best recognition rate from the system. So it was a combination. So my key point here would be, at least for today, would be always to combine criteria coming from the user, like what is the most preferred representation, this one, but also combining the system aspect, which is here the recognition rate. So by combining the most preferred representation and the best recognition rate, we decided which representation has been incorporated in the system. As you can see, most of them are very well recognized. And usually we say that a recognition rate above 90% is quite good. It's like for natural language recognition. Usually people say that for natural language speech recognition, if I don't have a recognition rate above 90%, then it's likely that people will reject the system because they expect the system to recognize their voice quite accurately. Fortunately, those which are below the threshold of 90%, they are not too much far away. So for instance, the toggle button, this is the most preferred representation. That's fine from the end user point of view, but from the system point of view, it is only recognized in 80% of cases. So not so good. Another area where it was very important to combine not only user representation, but also system recognition is an example here for detecting microcalcification on X-rays. So usually physicists, when they look at some X-rays, they identify some zones, like here. There are some zones where something needs to be further investigated, and they draw something like a special drawing representing areas to be further investigated. Like for instance, this is one gesture. This is a normal one with a novel. This one is very dense. So all of this representation should be not only well expressive for the end user, who is a physicist in this case, but also well recognized by the system, which is not so easy. For instance, differentiating a circle with that one which is supposed to be a novel is not so straightforward. This I will skip for a moment. So another example of gestures, but this time not with fingers, but with a stylus. It is a system in which we participated several years ago called Doctoon. Doctoon is a system where a child in a hospital can interact with a character displayed on TV. So, of course, when the child is in let's say, maybe in critical condition, in a hospital room, the child is suffering and can only be distracted by maybe cartoons or things like that in order not to think about his pain. So in order to operate this character that you can see here on the left, there is a psychologist in another room who is using this interface for gestures. So the character which is displayed here and then sent over the network can be manipulated by gestures, for instance, in order to convey some emotions. For the moment, the character is joyful, but if I want to say, I want to have a transition from, let's say, a position where the character is smiling, so that's the first one, to a character which is no longer happy, but maybe who is hungry. So I have to go from this initial state, go through the neutral position, and then end up with a gesture until the regions where it is depicted as hungry. So if I want to do that, in order to create an animation, I will produce a gesture, something like this. And the speed, or the time that the speed of my gesture will also regulate the animation. So if I'm doing this slowly like this, then the transition from happy to hungry will be smooth. But if I'm doing something like this, poof, then it will immediately go to angry. Or if I want even more, I can go from happy, then stay a little bit in neutral position, and then going smoothly to angry. So in this case, the animation will go smoothly from happy state to neutral, and from neutral to angry. And of course, I can animate also other aspects like the hands, blinking eye, or also the background, etc. So the nice thing is that the psychologist has only one screen, and with the hand, or with the finger, or with the stylus on the tactile screen, producing this type of gesture will create an animation of the character that will be sent. This I will skip for a moment. So there are many parameters that need to be taken into account when designing gestures, but also the time to complete the gesture itself. If I compare, for instance, the keyboard shortcuts for cut, copy, paste, etc., which are pretty familiar, although I'm not sure that maybe, do you know why Ctrl Y is chosen for redo? I'm not sure that many people know why. Of course, X maybe stands for cut, like a cross. C for copy, that's still is still easy to remember. Paste is like including or inserting something where I am. But why Ctrl Y is selected for redo? Does anyone has any idea? B stands for bold, that's okay. But why Ctrl Y for redo? So maybe this shortcut is fast, but it's not easy to remember. It's Ctrl Y because it comes from a very old Unix command called yanks. And when we typed yanks, it was redoing the last things. So it has been imported from that. So if somebody is familiar with old Linux command, then maybe this person can remember the command, but otherwise it's not so easy to remember. So it should be fast to produce, but also easy to remember. A second thing is that, well, another criteria that needs to be taken into account when designing gestures is, as we said, the degree of consensus, but people can articulate or can produce the same gestures in many different ways. So here is an example with just stars like this. So the expected gestures is something like this. A small star consisting of 3 strokes, but depending on people can start from the top one and then the right one and then the horizontal one, or they can start with, why not, the horizontal one then coming this way and that way, or even maybe something like this, why not? So as you can see in this example, there are many variations of how people articulate the same gesture. So even if I say this is the gesture that should be recognized by the system, consisting of 3 strokes, people can articulate the gestures in many different combinations, different orders, and different directions. So in order to do so, there are some tools which can be used in order to detect the differences between the various gesture productions. So for instance, with this tool, it can be recognized that when one person produces a gesture, let's say, like again here for the example of this gesture. So if one person has to produce a gesture for reproducing this star, it is likely that this person will produce it in the same way. So that's fine. It is so-called internal consistency. So when a user is producing a gesture, this person is likely to reproduce the same gesture in the same order, same combination, and same direction. When that's for one user, but when, so the consistency rate is is usually very high. It's likely that the same gesture will be produced. And in this case, it's about 90%. However, when different people produce the same gestures, then it goes from 91% to 50%. So it means that the various gestures are not so consistent with each other. And it depends also of the type of gesture. For instance, in this graph here, you can see that for numbers, well, still people are more consistent with each other, but for shapes, the variation is very significant, or even with symbols. Why is it so? Because if, for instance, I have to ask, please draw a 7, me as a user, I will produce a 7 like this. Maybe somebody else will produce a 7 like this, and then a cross like this. An American person will produce something like this, or maybe something will produce something like this, and then something like this. Why not? So for some symbols, there are very different representations, which are not consistent. So fortunately, there is a tool called Gecko, which you can download here from. It has been developed by Daniel Ratavu from University of Suceava, in which you can upload different gestures, and the system recommends you to remove or to add some more variations of gestures in order to make it more consistent. So consistency is key. Now the accuracy of the production is also an important criteria. For instance, if I have to, again, if I have to write a question mark, something like this, I can have many variations, not only in the order. For instance, I can start with this symbol and then the circle, or I can do the other way around, starting with the circle and then something like this. Or if it is if I'm a Spanish speaking person, then I think I will have something like this. No, not this way, the other, it should be symmetric, so something like this. The question mark is inverted. So there are, again, different accuracy. So if the reference, again, is this question mark, in order to reproduce it, I should be very precise, because if I'm now producing another variation of that, let's say with another color, so I'm exaggerating, of course, if I'm starting with something like this, then it's likely that this the black gesture will not be recognized as being a question mark because it's too different from the template. So by examining a large set of variations, Radu Vatavu identified the so-called average gestures. So here you can see many variations of a question mark, but the mean or the most common path is the one. So this is very expressive for feeding a gesture recognition system. So this is something that we will see later, is how to feed a gesture recognizer with the best templates. And there are many parameters for that, like geometric accuracy. So it means that to what extent the shape is the same. The kinematic accuracy, to what extent the speed is the same. Again, for instance, let me show you, this is, let's say, a variation of my own signature, right? So this is a gesture. If somebody wants to reproduce my own signature from the drawing, it's likely that a very well-trained person will reproduce it quite easily and quite accurately. Maybe like a bandit want to reproduce my signature, it's likely that he will reproduce again and saying, okay, this is my gesture again. Oops, this is my signature. So the symbol will be quite close. However, the kinematic accuracy would be quite different because only myself, I know my own signature, and I can only reproduce my own signature with the same speed, the same acceleration, and the same difference. Like if, for instance, if I'm saying here in the last part of my gesture, I'm accelerating, then decelerating here quite slowly, the bandit or the person who wants to reproduce my own signature won't be able to do the same. Maybe it will be slower on the first part here, and then not accelerate, and then going slowly to be very precise. So again, there are different possibilities. And there are also other measures like articulation, accuracy, etc. So there are several measures. These measures can be also visualized with heat maps, but I will not detail them here. The nice thing is that there is a tool that helps designers to do so. So for instance, on the left here, I have many variations of the alpha gesture, smaller, larger, etc. And the most common alpha is this one. So this is very handy for feeding a gesture recognizer so as to guarantee that the recognition rate will be good enough. Again, this is an example with confusion matrices, and the system can also display all the variations of these gestures and tell me in which one can be confused with which one. So for instance, here the diagonal is of course the best combination, which means that, for instance, this gesture is properly recognized in most of the time because it's here. However, there are some others where there's some confusion, like for instance, the question mark can be confused with this one, which is the right bracket. So again, with this system, I can visualize what can be the confusion between average gestures. So again, my point today is to show that there are so many different criteria in order to be taken into account for designing gesture that it is probably impossible to take them all into account. If I have people having perceptions problem, like maybe vision impairments or motor impairments or cognitive impairments, then the gestures are even sometimes more difficult or more unfamiliar to produce. So here is an example of, on the left side here, you have so-called familiar gestures, like a gesture for figures, for letters, for similar shapes. So this left side, probably everybody knows these gestures. If I am to ask a rectangle, well, people can of course do this, or in another way, or maybe with different combinations. But if I have to ask them, please draw me a sailboat, for instance. So the familiarity of the right gestures is not so common. So people have to look at some reference in order to reproduce the gesture. So this means that familiarity of the gesture is also important for people to reproduce the same gesture. So in order to test this, here those two sets of gestures have been compared with each other with respect to two things: rating versus ranking. Rating is that which one, to what extent do you think that it is easy to execute? Like 1 is very easy and 5 is the most difficult to execute. It means to reproduce. And ranking, which one do you prefer? Is, for instance, let's say this one I prefer to sketch or to produce this gesture as opposed to that one. Or maybe this one looks more familiar or more easy to produce than that one, whatever. So everybody has some opinion on that. And then when we compare all of these things, the observation from this experiment is that the more difficult a gesture may look like to the user, the more, no, I'm sorry, the other way around. The more time a user may need to produce a gesture, the more it is perceived as difficult. So again, if we go back to my example here, this gesture, I only need one stroke. So it looks like simple, but if I can reproduce this gesture very quickly, let's say in a very short amount of time, then people will say that this gesture is simple. So even if the gesture maybe is a little bit unusual, let's say if I have to do this, so this is again a unistroke gesture because the gesture consists of only one stroke, then it means that if from a perception point of view, I only need a short amount of time to produce these gestures, then I will perceive it as an easy gesture. However, for the other one, like on the back, on the bottom here, if I have to reproduce this one, maybe with another color, if I have to reproduce this one, as you can see, it will take me some more time for doing so. So if I spend more time to produce or to reproduce this gesture will be perceived as more complex. Second is that when we elicited gesture from people, when we ask participants, please give me your gesture, again, their rating is very much related to the perceived difficulty. So when people, even if somebody suggests a gesture, even if it is a complex one, the perception of the gesture will depend of the rating. So if, let's say, for instance, if I'm drawing an alpha, for me, maybe this is an easy to produce gesture, not just because it is a one stroke, but because I am familiar with it, but maybe somebody else will not be familiar. Or if I have to draw an infinite one, okay. But if I have, for instance, to draw an integral sign, I can't assume that everybody knows that this is maybe not a S or a strange S, but this is the sign for an integral. Or even if I'm doing something like this, and this is a sign for an integral on a complex closed domain. So I don't think that many people know this symbol. So even this, if this symbol may look like familiar to me, it will be not familiar to somebody else. And this depends on the difficulty rating. This I will skip now. So in order to...
Jean,
yes?
I have a question.
Yes, please go ahead.
Yeah, I think there are two aspects: the cognitive complexity and physical complexity. And the time you mention, the time for completion is of course physical complexity, and familiarity is of course cognitive complexity.
That's right. Mm-hmm.
Did you look into that? This dissociation?
Well, here what has been done in this experiment is something like this. So it's more about the physical complexity and not the cognitive difficulty.
Mm-hmm.
Is that independently of, because there were different people, but we didn't correlate, or at least we didn't find a strong correlation between the cognitive complexity and the physical complexity. However, it was the other way around, is that when a gesture consists of more points or more strokes, it was perceived as more complex.
Okay, yeah. That's a second point I wanted to make. Some figures seems to be more complex in terms of inflection points. And in terms of muscular order, you have to change direction. You draw this alpha sign, it's a curve. It's a very simple figure. And from a muscular point of view, it's more or less the same order all the time. You don't have these inflection points where you have to make different segments and so on. So probably there is also a kind of physical complexity issue which is related to these changes of directions. From the brain point of view, you have to. It's like a procedure in a program. You have different sequences of steps and so on.
Exactly.
So did people look into that?
Yes, we did that, but for the sketching part, maybe I'll come back on that, unless I have something here. No, here it's mostly the amount of points and the amount of strokes. So for instance, in this gesture set, of course, as you said, if I have to draw a circle, whether I'm familiar with it, yes or no, it is very straightforward to produce. But the omega, independently of the fact that I'm familiar with this Greek letter or no, I have to produce one first, then I have to stop, and then indeed I have an inflection point, and then I have to reproduce the second part. So in this observation, it's not the case, but let me go back maybe to one that we had with the sketching. There we made this experiment. Let me see where it was. Okay, there it is. So in this table, what we obtain as a result, let me highlight. I said initially that there were two aspects: the best representation coming from the user, or the most preferred representation of a widget, and also the best recognition rate. But what we saw also is that the perceived physical complexity was highly correlated with different things. So if you look at this part here on the table, on the right part, oh, I'm sorry, there are some constraints like inclusion of shapes, or intersection of shapes, or shapes were close to each other, or depending on the size. So as an example here, in this representation, again, let me try to write it more precisely. So this is the most preferred representation for a text field. It consists of drawing one rectangle. Oh, I'm sorry. One rectangle, okay, more or less, and one straight line inside. So here, there are two constraints. First, I have to draw two strokes, and the straight line should be included in the rectangle. I cannot, of course, have maybe this rectangle like that and something like this. Otherwise, this will be confused with another gesture. So when we categorized all the orientation of the gesture, the inclusion or the constraints, these are highly, as you said, for instance, like the inflection point, they are highly correlated to the perceived physical complexity, independently of the familiarity. So another example here is, in order to draw the list box, the most this one, the most preferred representation was one rectangle, then two lines in it, and then on the right part, two triangles, which are included in this rectangle on the right part of the rectangle. So here you have many constraints. You see, we have a specific orientation. We have also a complex inclusion, because the two lines were physically included and the two arrows as well. And we have some sequence, is that of course the two triangles should be at the right of the left lanes. I cannot, for instance, if I drew something like this with the triangles on the left and the straight lines here, this is not the same, of course, and the size. For instance, drawing small triangles inside a rectangle is more constraining from a physical point of view than maybe a free form. So the example of the inflection point that you gave is a typical example of such a constraint.
Okay, thank you.
Does this answer your question?
Yes.
But unfortunately, so far, so this is for the physical complexity, as you mentioned, but we tried to make a good mapping between what was here on the left. So here on the left, let's say this is the most preferred gesture. So from a cognitive point of view, it should be the most familiar, but it's not because it is the most familiar or the most preferred that is the best cognitive complexity or the lowest cognitive complexity.
Yeah, my feeling about this example is that it's a little bit different. I think you are paying more attention to the shapes than to the gestures. So for me, that's not exactly gesture recognition. That would be more shape recognition. Would you agree with that?
Yes, a shape recognition is a particular type.
Yeah, because the temporal aspect of the gesture itself is not significant. It's the final shape, which it is, I think.
Right.
And the other thing is that you are not doing this in free space. Your gesture is on the medium itself. You can see it. It's drawing. So from a cognitive point of view, it's far easier, of course, because you have an immediate feedback of what you are doing.
Yes, that's right. And here it is a 2D. It's sketched on the surface, as opposed to mid-air gestures, where if I'm issuing gestures in the air in front of my camera, for instance, or with the armband, this is, of course, totally different.
Yes. If the gesture is complex, you have to produce a mental representation of your gesture to be sure that it's complete. It's very complex. I'm very bad at this kind of thing. I'm not at all a very geometrical person. So I know that this can be very difficult. But if the figure is really complex as some of the shapes or gestures you have shown, then you really have to mentalize and ensure that you have done all the steps. And they have to be related geometrically in order to avoid the problems that you are mentioning here. And in this case, it's a little bit different because you are drawing it, of course, and you have an immediate feedback and you can correct immediately also. So yes. So I think this is slightly different.
No, it's quite different. Maybe I can, during next lesson, for instance, I will talk about, for instance, head and shoulder gestures.
Yes.
not the brand for shampoo. So can you see my figure now? Okay, so I will show you that in another study we ask people, please propose us some gesture that you can make with the head and or with your shoulders, right? So of course we can turn the head in many different positions. We can draw circles, clockwise or anti-clockwise. What was really interesting to see is that, of course, from a physical point of view, we can have head gestures like bending, but at different locations. I'm trying to do it maybe more precisely like this. Of course, I'm not in front of you, but there are 3 positions. For instance, if I want to bend myself, I can keep my neck constant and only something like this. Okay, so this is one bending gesture, but I'm not very flexible. So usually people try to bend also with the neck. So this is something like this, right? Second category. But third category is that, of course, from a physical point of view, if I'm trying to bend like this, even with my head and my neck, at some point, my torso will also come. So this is a third category. So when we ask people, can you suggest some head gesture for, let's say, moving up and down? Some use something only the head. Some people were also using the head and the neck, and some people use all the torso. But in order to recognize that, especially, for instance, for Mehdi and Thomas who are familiar with Kinect, this is very difficult to distinguish. Of course, most people always do a little bit of all of them. Almost nobody do that exactly only with the head or only with the neck or only with the torso. Usually we are trying to do it with a combination. So again, in these 3 types of gesture, the physical reproducibility of this gesture is difficult. And from a system point of view, it is even more difficult to distinguish them. So in the end, when we ask people, could you reproduce that, they were almost unable to reproduce the same gesture. They all agreed to say, okay, I will bend my head, for instance, upwards, or I will turn this way, or even moving with my shoulders. And next time I will show you the complete taxonomy of these gestures. But they were almost unable to reproduce the same gesture because of that. So what we did, and or maybe if you well, maybe I can do it. Since you're raising this question, if you don't mind, let me try to find out if I have. I think this should be this one. Just a minute. I'm trying to find out where I did this. Just a minute. I'm trying to find out where we did this. I remember that I had some slides on that. Okay, so let me share that with you now. Well, it's a sneak preview of next lesson, but anyway, since you're raising the question, so I think that you can see now my screen, right? Mm-hmm. So we ask people, could you suggest head gestures or head and shoulders? Of course, head and shoulders is a trademark of a shampoo brand, but head and shoulders is like that. Huh? So from a physical point of view, if I go here, then I can move my head in according to 3 planes. And you, since you are an expert in aviation, you can recognize the yaw, the roll, and the pitch. It's the same for the head.
I agree.
Of course, some physical movements are more complex to perform than some others. Like pitching is maybe more difficult for me than rolling or yawing. And what happened is that when we collected all the gestures and we tried to come up with a taxonomy of this gesture, we did it. This is something like this. So for instance, when there is a series of gestures for X, Y, and Z translation, so of course I can move the head like left and right, or up and down, or thrust and retreat. But these are very, very difficult gestures to reproduce. Although people recognize the gesture, they are difficult to reproduce. And even when they try to do it, they don't remember it quite easily. And there are many like that. I think that this is a second one. Yes, so here you can see that bending, for instance, my head down can be done only with the head, or the head while keeping the neck constant, or it could be with the neck and the head but keeping the torso constant, or moving all the three. This, for instance, bend forward is the case where the torso, the neck, and the head are moving. But again, when we ask people, please reproduce a bending gesture, they don't remember whether they have to use all of these 3 parts. So we'll elaborate on that next time. Do you want to add anything else? Please feel free to.
No, I will switch off my micro. Thank you.
Oh, no, it's okay. Thank you.
Can I ask a question? I mean, just something I didn't understand. As I understand, during the gesture elicitation study, we ask the user to propose a gesture to perform some action. That's and right. The user proposes this gesture. But typically, the user does not go through a complete interaction session. So if there is an interactive system, the user performs this gesture several times during the interaction session, a complete interaction session during use in the real world. I don't know if the difficulty of the gesture that is proposed during the elicitation study takes into consideration how often this gesture will be performed during a typical interaction session. So maybe the user may consider the gesture easy to perform during the elicitation study, but if a particular gesture needs to be performed, I don't know, several times compared to another gesture during a typical interaction session, the user may find it difficult at the end of the day. Is this something which is interesting? And if it's interesting, how can this be considered in elicitation studies or taken into account in elicitation studies?
So thank you for your question. But indeed, frequency is one criteria among others. So let me switch maybe the point that I want to conclude today, and I will add that what you just said before also, is that in order to design a usable set of gestures, we have to balance several criteria. criteria coming from the human part and criteria coming from the system. But there are so many different criteria that it's impossible to take them into all account. What you said is that, for instance, we have been talking about recall rate, we have been talking about consistency from an end user point of view, or even fun, if you remember the viewing position. But here you can also use frequency, right? Or you can say maybe criticality. So there are different factors, different criteria that needs to be taken into account. But in gestural elicitation study, usually people propose one or two gestures for one action. They don't reproduce it several times. So if we have to take into account the frequency of these gestures, we have to tell them, please also think about how frequent you could reproduce this gesture. So it's not just memorability. Memorability is key, because if the user does not remember the gesture, it's the end of the world. No. However consistent or funny or socially acceptable they are, if people don't remember, is no point. But if they remember, then we have to take into account other things like frequency. Why not? Especially if, for instance, I have to reproduce the same gesture several times. For instance, for head and shoulders gesture, this is not, this is a good example where frequency can come into account, because, for instance, if I have to turn my head all the time, after 5 minutes, I will be tired enough and I will no longer use this type of gesture, of course.
I had a bit of, if I can follow up, a bit of a related thing, and maybe even the frequency itself, because I mean, if you have something like a gorilla arm or something like that, so you might even not have a high frequency, but just the position and how you do the gesture might lead to, that you get quite tired in doing it. I mean, we had that with some Kinect gestures where you have to hold your arm straight out, and I mean, it's not a high frequency, but you get very tired. And I think that's quite interesting, related to Katoma's question. Yeah, could people imagine that? I don't think so, right? In an elicitation study, it's more like memorability and these kind of things, but I think it's hard for them to guess whether they would get tired in doing that gesture, right?
Mm-hmm. So in this case, yeah, you're right. In this case, if we have to take into account these things like frequency, criticality, or fatigue, which is not a criteria, let's say, if they don't reproduce the same gesture several times, they will not experience the fatigue of that gesture. And we know that there is the problem of the gorilla arm. The gorilla arm is that after a while, if I produce the same gesture, I will be very muscled with this gesture, or even if it is with my finger. If I can you see my finger, for instance? If I'm performing micro gestures, maybe after a while I will become the Arnold Schwarzenegger with a bit muscle here, because I'm always doing something like this. Well, people who are moving their fingers with smartphones, they have very flexible hands, but in the end, it's also very tiring from the musculoskeletal point of view. So indeed, Ketoma, in gestural elicitation study, we don't cover this criteria. So this is why they should be taken into account in another experiment. Like, for instance, I will talk about that during the next lesson, is that when we have gathered or we have collected the gesture proposal, one thing is that we can put this proposal into a real system, and then the same participants experience whether they can use it on a regular basis, because it could be the best, the most consistent, the most funny gestures, or more the easiest to learn and to reproduce. We cannot assess the frequency of the fatigue induced by the muscle. Although I know, but I'm not familiar with that. I know that there are some people who are manipulating so-called musculoskeletal models, and they can already predict the fatigue of the movement. I know that there are some people in Greece, they are doing something like that. Dimitris Tsovaras, for instance, they have a physical model of all the movement of the human body and the difficulty of such movement. So if, for instance, I have to do something like this, let's say, they can predict, well, this gesture will have, let's say, a score of 6 on a scale of 10, something like this. But their model does not work for all gestures. I was also dreaming of a model which can predict the complexity or the fatigue of a movement even before using it. But he told me that this is not done today. It can be done for a few movements like that, but not for all human body. I mean, all movement of the human body.
I have a remark about that. I was thinking of machine learning, which is quite new, I would say, compared to these studies, which are dated for some of them for 15 years. And these techniques did not exist at the time. So I understand that in the past, what you were doing, you were designing your system of symbols of gestures, and then you would implement them, and then you would come back to the user several months later and so on. So it's still the traditional V design with the waterfall model. And I was thinking, okay, humans do not work like that. And if people land on an island and meet other people, they will define naturally some kind of language to interact. And they will define the gesture by themselves, taking into account the difficulty of producing and remembering them, and also the difficulty of understanding them. So this is something which evolves and which is done very naturally. Humans can do it. So I was just thinking that the best solution, maybe it's a little bit futuristic, would be that the system and the humans all together work together and co-evolve their language. And the system learns to distinguish and associate gestures to the meanings. And related to the previous questions, this is produced in a very natural setting. And if you have to do tons of gestures and so on, you will feel the fatigue and you will adapt immediately. So it's a kind of in situ learning and design. And I think in the end, this could evolve in this direction because the technologies are now allowing to do that. What do you think about that?
I think at least I can perceive two different questions in what you are saying. The first thing is the fact that indeed the gestures can evolve and they are not necessarily the final one. So again, in our example here for sketching, although it is gestures based on shapes, I said, so these are in this column, these are the most preferred representation, and there are some others like these, the first, the second, and the third most preferred representations. But in the end, in the system, some people said, well, all of these representation, I don't like them. I have another one. So can I draw my own gesture for representing, let's say, a label or a radio button or whatever? So we introduced indeed a system where people can customize or replace the already embedded gesture by their own. Of course, then they had to produce them by themselves. In this case, we asked them to produce 3 templates. So if, for instance, they said that, no, I dislike or I don't like this gesture and I want to introduce my own gesture in the system, then they have to provide the system with 3 examples. So that's one thing, and this is based on pattern matching. Now that's one thing. The second thing is, yes, when you said there is a co-evolution, is that right now the machine learning techniques are very efficient in order to classify gestures, and there are many of them, but they are not so efficient in order to reclassify everything in real time. So let's imagine that I have a set of, let's say, 30 gestures, and you introduce a new gesture. Let's say, okay, welcome aboard. So this is your gesture. Bert is doing the same, but in the other way around, and Ketoma is something like this. I don't know. So we have to introduce 3 new gestures in the system. So in order to add those 3 gestures in the system, the model behind needs to be retrained. And doing that now is still possible. Machine learning techniques are efficient. And this is so-called real-time adaptation of machine learning. You need to retrain or to remodel or to retrain, re-entraîner, to retrain the system with the new gestures. It is still doable, and the technology now is becoming really fast. In the past, it was taking maybe some hours, sometimes it was some minutes. Now it's half a minute. But if you agree to spend, let's say, half a minute for the system to be retrained, to wait for that, and
of course, yes,
the system will recognize what you are saying or what you are doing. If you agree on that, that's fine. But I think it's just a question of time. Is that I know I'm not familiar with this area in machine learning, but I know that in some area people are working in so-called real-time retraining. Is that when some new templates are introduced, or some new things are introduced in the system should be retrained so as to reclassify everything in almost real time. But I think that from what I know, or from what I have learned, now there are some systems which are quite close to do that in real time, almost. But of course, it depends on the problem. I didn't test that with gestures. So in order to support what you are saying as co-evolution, I think it's just a question of time. Probably machine learning will be efficient enough in a short amount of time in order to do this adaptation in almost real time.
Exactly. Because then the people are really experiencing their symbolism immediately, and they can experience the gorilla arm if it occurs, and so on, all this stuff in real time. Because otherwise it's a kind of intellectual design endeavor, and it's very difficult to predict the difficulty, the cognitive, the physical difficulty, the recognition rate, and so on by the systems and so on. You spoke of musculoskeletal models and so on. It's very difficult, and these are models in the end. And I think the best way to design these things is really to co-evolve things on the user side and the recognition side system without any theory in some way. You don't. No. You see what I mean? It's
a continuous adaptation.
Yeah, exactly. Like when you and I we are great friends, but we met one day and then we co-evolved our relationship and our way of communicating, our jokes and so on. So it's really about co-evolution to build a communication. And I was thinking it's human-machine interaction or communication. For this kind of topic, I think it would be interesting, because trying to fit gestures into very strict thing, which may be overthought and very intellectual and theoretical, maybe it's not the right way. It's like in language design, where you have people who have designed Esperanto as a universal language and no one uses it. You see, it's not natural. So that's a general philosophical reflection, but I think it has some meaning, and I think now the technology can evolve towards that.
Yes, and even, for instance, if when we communicate, we may want to try some gestures. Let's imagine that I want to meet somebody that I don't know and I don't understand his or her own language, so I may try some gestures. If it works, I can reuse them, but if it does not work, I have to switch to other gestures, which is not the case here. Again, on my screen here, although we spent a lot of time in order to come up with the best representation, the best recognition rate, the best complexity, and when we gave this system in the hands of designers, they said, well, for me, this is not my most favorite representation, or when I try to draw it, it doesn't really work, because, for instance, the toggle button here, again, if you see the toggle button, sorry, not that one. Okay, the toggle button is only recognized with a recognition rate of 80%. So maybe an end user will not be happy. So it says, okay, let's forget about this representation and let's go to another one. If it works, then it's likely that this representation will be kept. If it doesn't work, then it will be replaced by another one. And this may last forever. Perhaps, I don't know.
Yeah. And when I'm speaking of co-evolving, I mean it's a set of users which co-evolve a language to interact with the system, and then it becomes standard. Of course, it's not one-to-one, and I mean if you get the system, you are going to define your own language. No. You can impose the language within the system for future user, but at least the users which design the system or the linguistic system, I would say, they co-evolve the language until they find they are able to communicate what they need to communicate with the very economical moves, physical moves, gestures.
Mm-hmm.
Just thinking about
that's right. So it's a perpetual evolution until there is a not just a consensus or an agreement, but an efficient point.
Yes, and this echoes Thomas' remark, which is really about, okay, practically, how is it going to work? It's very difficult to predict. So the best way to predict it is to do it, as Alan Kay was saying about the future.
But you could also say it's just a kind of an extreme case of user-centered design, right? Where you say the user is building
exactly.
the whole. And I mean, I wouldn't limit it to gestures, because you could say the same for a graphical user interface. Instead of giving you a fixed interface, you could also say users can actually define themselves how it should look like, because it's also different. Everybody says, for me, this menu is not good. We have some adaptation there, but I think you could use the same approach that you now just mentioned also to co-evolve a graphical user interface and have maybe something that is very much driven by the users themselves rather than an expert designer who maybe thinks what's best for everybody.
Exactly. I think in the field of design, things have really drastically evolved, and we are all trying to use MVPs, minimum viable products. You start with something and you experience it and you build on it and so on. It works far better than this waterfall model. Waterfall model needs to rely on theories, and the theories are always false.
I would not say they are always false, but at least it provides us with a good starting point. But it's a starting point always to evolve from this starting point.
Yes, but they have their limits, and they are based on hypothesis simplifications and so on. It's nothing like the real world. So it's probably best to combine both of them, but I'm really surprised by the efficiency of these iterative approaches, where you have something and then it evolves. And so my remark about co-evolving the language is really about that. Start with something and put it to use, and then you see how it evolves, and then it converges to something which seems to raise an optimal state where it will not evolve in any direction further, and then you keep it. Mm-hmm. And it has been tested and designed by a pool of users.
Right, and so this is something that is. Thank you for that point. But because here in the human criteria, which was my last slide. Mm-hmm. One thing what is really missing here is indeed that, of course, we have all of these criteria, but one thing, and maybe this is not just human or system, it could be maybe, as we said in the mixed initiative, and when there is a collaboration between the system and the user, so I would say system and human user. So here it's evolution over time. Mm-hmm. That in the approach that I've just mentioned before is something in order to design a first gesture set. Of course, probably we try to do our best in order to make this gesture set doable, but it's likely that it will inevitably evolve over time, not just because it is bad, but because there are some other things like the fatigue or the frequency that Ketoma mentioned, or because of other aspects that are not, or that were not taken into account when we designed the first gesture set.
That's what I meant by theory. You take into account some variables as input variable to make your decisions and so on, and you don't account for all of them because, well, we are humans.
But that's maybe now you have it over time. But if we go back to an example you had earlier, I think also the context would be quite important, because even for the same user, the gesture might change, right? You have the person lying on a sofa controlling a TV. Exactly.
exactly.
And then I have different, for the same operation, I might want to use different gestures from a single user. So I think it's quite a complex problem, because you can even not say it's one dedicated gesture from a single user or a group of users that works best, because it might even depend then on the context in which you apply the gesture, actually. So I think there is evolution over time, but then you have a second dimension, which is maybe some context that comes into play, that you might have different versions for different contextual settings, actually.
And
again, if the context change, the evolution will even change also. And this is the area of so-called software evolution that is very expanding now.
Yeah, but it's like parallel strands. I think the evolution can then go on over, because I think it's not one or the other gesture. I think it's just depending on the context. I might have 3 different gestures to do something, just because one works best in a given context, you know. I mean, it evolved over time, and I say this is the perfect gesture if I'm lying on the sofa, but this is the perfect gesture to control the volume if I'm standing in front of the TV. So I mean, I think, yeah, it's quite interesting, that in the end you want to maybe have this flexibility somehow. But then of course things come up like memorability, discoverability. I mean, we didn't discuss that, but of course, how do you discover then these available gestures? I think that's also a big question, right? Because in traditional user interfaces, you can just play around. But if you have now these very evolved and adapted gestures, how do I know about them? I don't know how you see that, Jean, but I think that's always a major challenge, right, in these interfaces, to introduce the user to the different gestures. Of course, you can do a tutorial, but nobody follows tutorials and things like that. I mean, classical example with mobile phones. I mean, you don't read the manual, you just see maybe from a colleague that you can use this or that gesture, and suddenly after half a year, you learn about a new gesture. You never knew that it exists on your phone, actually.
No.
Exactly, yeah.
So,
and
yes, go ahead.
And Jean, I presume there have been studies about natural gestures, because humans between themselves, and Beat is making a lot of gestures when he's speaking. So we use gestures all the time. But I was thinking about the sofa example. Maybe these gestures that we use are robust to these different body positions, and they are the product of a selection. Naturalistic selection and evolution, and maybe we have a very limited set of them, maybe 6 or 7 of them, because we can use them in all bodily position, more or less. So I presume there have been studies about these natural gestures, and maybe try to understand the principles behind their selection.
Right. Again, as a starting point, I like the example with the head and shoulder gestures. I think now we have probably the most detailed design space for all these gestures that are all possible, right? So I compare this taxonomy of gestures with other taxonomy that we have seen, and we have probably the most complete one. But this is not the end of the world. It's just the starting point. From this set of gestures, we said, okay, this one will never be used again because it's just too tiring, or this one is just too complex to remember. So we, in the set of all possible gestures, so we discard this one, we discard that one. This one will keep it for a moment, and then if users can test it, and then it looks like they will keep it, yes or no. So it's like converging to a subset of gestures that combine all of these criteria to some point, but making it rational. I even dreamed about a function which can maximize all of these criteria at once, but it's impossible. I can't do it. But starting again, there is another study that maybe I'll show you as a sneak preview for next time, to give you the flavor of it. I think this is that one. Let me open. This is for next lesson. Let me see. Again, yes, here is another example. So we come up with a consensus set of gestures with a ring device. So a ring device is exactly like a normal ring. You can wear it on one finger, or you can have on 2 hands. You can roll it, you can push on it, you can tap, you can make physical gestures joining, you can roll it clockwise, counterclockwise. So we came up with a taxonomy of almost all possible physical gesture with the ring, but in practice, most of them, I would say even about 70% or 80% of them, nobody used them. And here on the screen, with, for instance, with one ring, you can see that there were 2, 4, 6, 7, 8, 9 gestures. So even if we have maybe 50 possible gestures, or even more, people will only use in the end, I mean on a regular basis, only a few of them. And it's after a while, after evolution, that this consensus test will become the so-called de facto standard. Like we all know now the pinch in and pinch out. This gesture has now become a standard, and everybody is using it, whatever the platform is. But for ring device, we don't know yet. There are not hundreds or thousands of users around the world who are using ring devices, because they are, even if they are available off the shelf, there are not thousands of users who will buy such a ring in order to interact with your smartphone, right?
So what you are saying is that the nature of the device constrains the vocabulary, and it will evolve naturally towards a finite set of symbols.
That's right.
Okay.
So and performing this observation and these studies that, as I've briefly introduced, well, we really start from the most complete set of possible gesture, I mean, from a physical point of view, and then we progressively evolve to a subset by elicitation, by testing, and then even when I will show you that also with another example with very large screens. We started with a very large gesture set. Then we performed 3 elicitation studies in order to refine it. And in the end, it's just maybe 10 gestures for manipulating the whole interface. And from a practical point of view, even some people said, well, yes, but this gesture maybe, I don't know, this one would be nice for shaking a picture or shaking a video, but the other one will do this or whatever. And in the end, they progressively converge to a very small subset. But in order to get this subset, we need, and again, this is a good point as a conclusion, we need to evolve over time. If we don't proceed that with over time, we'll never converge. It's just one step. So in my slide here, when you see the consensus step, the consensus set, I'm sorry, this is one step in this evolution, but it's frozen today. So we should do another one, another full testing, maybe not an elicitation, and then the subset will converge again. So I see it as a convergence process.
Exactly, but do you think it would whatever the starting point, it would converge towards the same final set?
No, I'm not sure.
Okay.
I'm not sure. Or at least there will be some significant overlapping, but I'm not quite sure that it will converge in all cases to the same subset. Because, as Beat mentioned, because of the context of use, if I'm using this device maybe at home, it would be different if I'm using it in a public display. Or
yeah, I agree. But given in the same context, do you think there is a kind of natural human universal thing, which means that they will evolve towards the same?
I believe it, but I have no proof of that. It's a conjecture.
That's what you said with the pinch. The pinch was invented, then it was selected, and then we find it everywhere. But maybe if it had been done elsewhere, the pinch would have been invented and selected in the same way, because it's maybe it has a lot of characteristics which makes it optimal. It's easy.
Right.
It's a natural movement. Even monkeys can do it, because it's a natural movement of the thumb and the finger. That's
right. It's an optimal combination of several criteria that I mentioned here. Maybe it's not fun, although maybe pinch in and pinch out is still fun. I don't know, but I can remember it. It is very consistent because pinch out is by
It's the reason why we have a thumb.
Right.
Yeah, biologically, that's the reason, is to make pinches. So it's very natural.
That's right. So this is why I think that some gestures will completely disappear, even if we identify them in the consensus set. Maybe some of them will completely disappear. So that's it, and some others will remain. But this is only if we can see that it is evolution over time.
Absolutely. And so the idea of co-evolving is really to make this co-evolution faster.
And do you see that only in the design process, or do you see possibilities? Because for me, ideally, you could really have this evolution also once something is deployed, but maybe the gesture set is not yet completely fixed. You know what I mean? So that in use, the thing could still evolve. But of course, often the problem is then more on the software side, because you don't give users this flexibility that they could define their own gestures, because otherwise you could use the users and of course track everything they're doing, and you could learn from that, right? And you could evolve to the ideal set, because normally I don't think you will have the time in the design, right? You cannot do this for 3 years before you have your set ready and you can deploy the product. So that's why maybe many of these products are deployed with a more of a kind of a designer driven or even system driven, because they say, oh, we want to have the highest recognition rate, and if we take these gestures we get a very good recognition rate, but they're maybe not ideal for the user. So how do you see that in the future, Sean? How could we give more power to the user, in a sense that we could make use of that huge power that is there from the crowd, because they could do this evolution over time, right?
Again, this is why I said in the beginning here, there is a difference between system-defined gestures, like those gestures which are predefined with the system, with the gestures that are defined by designers. So like, let's say, we are trying to do our best, but nobody's perfect, and it's likely that we will never get the best set of gestures ever. Even the user-defined, even when people propose their own gestures, after a while we recognize, and they recognize even themselves, that although they propose some gestures, in the end they won't use it. They would prefer something else. One example, one concrete example, again, with maybe I'll try to tailor also my next lesson according to that, is a case study where we had gesture recognition with a leap motion in front of a very large display. So we performed 3 gesture elicitation studies, each with 30 people interacting with pictures, with images and videos. And of course, the actions were more or less the same. Unless, of course, for a video, you can, of course, play, stop, forward, fast forward, which you can't do it with an image or a picture. But anyway, navigation or arranging or liking, etc., there were a set of concepts. So we had 3 gesture elicitation studies. So from that, we extracted the intersection of these gestures. We designed the first gesture set for the recognizer, and it was the recognition rate was quite good. And then we performed 2 physical testing. A very first testing with a small amount of users. There were 5 or 6 users, as far as I remember. And then they said, well, we don't need all of these things. It is nice indeed, but in the end, we're only using a few of them. So we discarded some of them. And then we came up with a second version. That is now the last version. I will show you. And there are, as far as I remember, there are about 10, maybe not more than 10 gestures. And the gestures are all the same for all the contents. So whether the end user is manipulating an image, a picture, a video, or something like that, for the basic actions, the gesture is always the same. And indeed, for instance, for zooming in, zooming out, not surprisingly, the pinch in and pinch out is there. And maybe it is now we will try. So this is the second or the third version. I will show you the video, and the system works very nicely. The recognition rate is very good. It's about 95%, which is excellent, I think, with a leap motion controller. But yet, we plan to do another evaluation now. I mean, user testing, not just an evaluation, with a larger amount of people. And I think that some of these gestures will disappear again. Or maybe not, but this we have not yet done it, so I can't tell you. But at least again, we started from 3 gestural elicitation. We had a lot of individual purpose, and we restrict more or less, and now we have a very limited one. So it's a convergence. But again, and it's no longer a participatory design approach. It's something that is embedded in the system, and the system keeps track of the gesture that are produced and recognized, yes or no. It's no longer a participatory design where me as a designer or as an experimenter or as a researcher, I say, okay, I'll think out of the blue, out of my head, this is the best gesture, and this will be incorporated in the system. So that's perhaps a very good conclusion, is that in the end, even we have to balance those criteria, the human one and the system part, is only the evolution over time which will go for some convergence. I think that's a good discussion. I think. Thank you very much for raising that. We tend always to think about the best design. We try to do our best to produce the best design, but even with that, and even with after many years of experience, we never get it right.
Yeah, exactly. Things have changed. You probably know of Starship, the new rocket by Elon Musk. They are iterating. There are 15. They are going to launch their 15th rocket, and they don't mind breaking them. It's the goal. The goal is to evolve and learn. It's a completely different way of thinking. I'm an old guy. I'm getting old, so it's not my culture, but I've evolved. I've accepted this way of thinking, and it's really, really efficient. And I like theories and so on, but we make mistakes because they are simplistic, and there is nothing like reality.
But I have to confess that I also started from this point of view for many years. As a software engineer, I always dreamed about a principle-based approach where I could design or predict or assess or estimate everything by design. But in the end, even if I'm adding some more sophisticated techniques, more rules, more heuristics, more meta-heuristics, I can complexify the system, but in the end, still, I will not get it right. Even if I'm, for instance, in the past, but maybe you remember, one of the very first projects where we automatically generate the user interface from models, it was a Trident project.
Use XML, yes.
Or even with use XML, at some point we had, remember, in one of the adaptation engine, we had something like 120 rules for adapting the user interface. And still, there were some cases where the user was completely puzzled because said, well, I have received this adapted user interface, but it does not match what I have to do. Even with 100 or than 120 rules in the system. And we spent, I think we spent 3 years to design and to define these rules and to program them in the system. And still, even with so many rules, and I don't think that there are many systems with an adaptation engine with more than 120 rules. And even if there are more than 120 rules, I'm not sure that we will get it right. Surprisingly. So I've dreamed about that for years, but I have to observe now that I will never be able to do that. Even if I come up with 1,000 rules, I will always forget something, or I will always disregard some aspects that are important, but I didn't consider them.
Exactly. Yeah. Okay, we do our best, and we evolve. Exactly. It's the same thing.
But I no longer believe in the completely predictable approach.
Exactly.
This is a very good starting point. I think with this type of study, we can already make some very good progress and have a very good starting point. But it is a better starting point than maybe with random or with system-defined gesture or with designer, etc. But yet, it's not the final solution.
Exactly. And if you think of software and applications, they are exactly like that. They are introduced, and 5 years later, they do something completely different. They have evolved, and they are following the market and the needs and the competitors and so on. So it's all about evolution all the time. It's impossible to design something which is perfect. And as Bert would say, it would have to be perfect to a context, but the context is evolving. So you have to follow the context.
Yes, it's a moving target.
Exactly. And so, and we, as you said, we are designing control room, and that's also something that I'm pushing. In the past, people were doing control room for 15 years, and then they would redo it and so on. And now it's not possible because the control room is doing something. It's providing services to the outside world. The outside world is changing. The services are changing. So their mission itself is changing. And if you changes the services the control room provides, then you have to change the internals of the control room itself. So what I'm pushing for is really designing for flexibility. It should be an object we can evolve easily and without us, the designers.
Mm-hmm. But that also been my question before. I think that should be a major push in a sense that we can involve then the users themselves more in evolving the system, because I don't really see that in many. Let's take a gesture-based interface. I mean, about which systems do you know where I still have some real flexibility as a user? Then maybe it's foreseen and they say you can do 3 customized gestures, but that's not what we are talking about, right? You really want to be able, and I fully agree with Jean. I mean, you should not throw out the designer, because I think we should start from something that is as good as possible, right? I mean, you don't want to start from a random set of gestures that will not work anyway. So I think it's this combination that is very interesting, yeah, where we can first do our best job, let it go and let it evolve then. But I don't see too much support for this evolving process at the moment. Of course, some of it might be the case that it was just not possible until recently, as Jean explained. If you have to retrain your gesture recognizer, it was just not feasible to do it. But I think for the future, this might be a very interesting thing to see how can we push more there, that users really have some flexibility. As Dennis said, it's designing for flexibility actually, and opening that up so that we.
That's right. And but again, real-time machine learning could probably satisfy a better recognition rate, or keep the recognition rate very high, even if I'm adding, or if my gestures are flexible. But still, I think this is not enough. For instance, there has been the concept of extra UI. In the past, it was called the meta UI. And the extra UI is an external user interface of a system where the user can specify things that need to be changed. So it's not just an adaptation thing. It's if in the past, let me see, I think this is something like this. Meta user interface for ambient environment, for instance. There has been some work on that. Okay, one of them was, of course, Joël Coutas from that, but a meta user interface in the past was a special user interface that is outside the user interface of the system, where the user can say, okay, I want to remove this, I want to have that, or I want to change this in a way that is so easy that there is no need to program anything. And I see that I see that there is even a special issue about that now. I didn't check that. Special issue on meta user interface for ambient environment. And well, in the area of ambient environment, this is a very specific context of use where indeed everyday users could probably tailor their device or their not just the gesture, but the user interface they are using in order to make it more flexible towards their own expectations and needs. So this is so-called, in the past it was called meta user interface, but now it's called extra user interface. Let me see if I can find some reference on that. Extra user interface. There has been a workshop on that for some time. Yes, maybe I should add some quotes.
You still know about the quotes. Young people don't know about them.
Yes, but I remember that there has been a workshop at some point about extra user interface, which is again not the user interface of the system itself, but another user interface that is outside with which I can interact in order to customize, to change my system, or to make it evolving, as you said.
Okay.
So that's a bit like our work on end user authoring. So basically, you give the authoring tool to the users, and they can then design their own user interface. So that's very much what
Yes,
Author is doing, in a sense, that you say it's not just the final user interface, but you give them the authoring tool. And often, as you said, it's then not a programming language, but more a kind of a graphical or doing by example or stuff like that. But then they can really, okay, I see. We have to look into that, Audrey, with this extra user interface. This might be another interesting venue to follow, actually. But that's very much, in a sense, what we try to do with the end user authoring.
I don't remember where, but I have to find out. I'm sure that we can find. There has been a workshop on that. I don't remember where, about so-called extra, meta, super user interface. With there were different terms in order to refer to this other user interface where the user can customize things. Usually, you can, of course, I can adapt my user interface inside the application. Like in PowerPoint, I can, of course, select this icon, or I can tailor this toolbar, but this is embedded in the software. The extra UI is something that is completely external, and as Denise suggested, which can maybe monitor what I'm doing and suggest even me, you are performing this action very frequently. Do you want me to put that maybe in front of it, or to make it more salient, or change something? And that's it, including for gestures. We are thinking about how to make an extra user interface for gestures. And of course, this extra user interface, although it's a graphical, should be, of course, itself manipulated by gesture.
Yeah. No, but I agree. That's what you want at the end of the day. That you give this flexibility. I mean, that's indeed what you need, and you would need it also. I think the best would be if that's not application bound, as you said. It should not be for a single application, but you should be able to use it across applications, because if I do a gesture, I might want to say I do this gesture and it should open this file in Word and at the same time do this or that. So I think that would be ideal, that we see it more as a kind of microservices that can be accessed in different applications, and then we can use gestures to trigger some of these things in multiple systems. I mean, in an ideal world, I think that would be really nice.
Especially to preserve consistency across application. If, for instance, I want to say this is swipe right for next slide, next image, next menu, or next whatever, or this one is for previous one, I want to keep those two, let's say with a Kinect, I want to have those two gestures, and I want to consistently use them across all applications, and which is far away from what we have today.
Yeah, absolutely. I mean, that was also some of the early critiques of Norman, I think. That, I mean, and we still have it, right? You mentioned the different operating systems having different gestures and so on. So I think it can very easily, and then even different apps within an operating system, right? They might still use very different gestures for the same thing. So that can get very complicated.
Again, if we look at that, and again, if we look at all of these gestures, and I think if we compile all of them from the most frequent operating system, well, we have something like maybe 40 different gestures. Although the gesture may be the same, like maybe a single tap, a double tap, triple tap, or double tap with two fingers, or with the left finger, the right finger, but they have different actions depending on the system. For instance, when my daughter is asking me, Papa, can you explain me this interface on the Mac, or how can I do it? Then I think, okay, now I'm not on Windows, so I should use this other gesture. So it takes me a while to think about, no, it's not that one, it should be that one. Or even I have to refer to that one, say, oh, okay, I should use maybe two fingers on the left part of the track pad, and then I have to do this in order to scroll down very quickly.
Also, it's a question of relationship between syntax and semantics. The gesture is syntax, and semantics is what it produces. And the design problem is connecting the two of them, and in some cases there are easy links between the syntax and the semantic, and then it makes things far easier. But when there seems to be, and as that's exactly what you said, the same syntax on different systems will have different semantics. And
but I think it could also be that different users even want to have a different mapping. So I'm not sure whether we always get a one user interface fits all, because
exactly.
I might say this is not the gesture I can memorize easily or do easily for do that. So I want to maybe reconfigure it. So, but of course, then you run into the problem that Jean just explained, because we have individual user interfaces, and how can you still talk about it?
So, but you still use the same set of gestures, but with different semantics.
But with different semantics, I think.
On my phone, that's what I did. I've a gesture for getting back on the page I'm in, and I've assigned it myself because it's an action I do very frequently, given the type of use I do with my phone. But if I were a different user, maybe I would not use this semantics frequently, and then I would not use this gesture for this semantics. So, so it's very good maybe to have the syntax and the semantics, and then people can connect them in different ways.
Fully agree that you can say for the gestures, we might evolve to some best gestures in general, but then you can map it with different semantics. Makes a lot of sense.
For many reasons. Again, as a very last case study, I know somebody who had an incident with a bicycle, and unfortunately he left the two last fingers. He lost those two fingers, so he only has 3 fingers, and the index has very little mobility. So he said, well, I can do one finger scrolling. Sometimes I can do it with 2, but it's very tiring for me, and it's painful because, of course, he still wants it, but he's working like that. So, for instance, here on my screen, the 3-finger double tap, or the 3 fingers whatever, this type of gesture will never be accepted by this program.
Yeah, I mean, I just wanted to ask, like, going along the same line, what Pia said about the context in which we interact. I think today we interact with technologies in many different ways and using many different interfaces. For example, you can be playing a music and you can change the music which is playing on your sound system on your phone. That would be like surface interaction, and you perform some gesture. But let's say you change the context and you are in your living room with some guests and you want to change that music. You want to perform the same action, but maybe using a Kinect camera, for example. You have to transfer that gesture also the same for the same action. That gesture which you have learned and performed on surface interaction, on maybe 3D mid-air interaction. Maybe this transferability also between different interaction interfaces is something to consider, I think.
Yes, so this is beyond consistency. Transferability means that if you learn and maybe you agreed and you become familiar with some gestures in one context of use, you may want to transfer them maybe into another context of use, maybe also with the same device or not. If, for instance, let's say I'm doing in front of my screen, let's say a clockwise circle or a counterclockwise circle in order to raise up or to raise down the volume of my media player, will I use the same system if I am in front of my smart TV, if I have one? Maybe yes, or maybe not. Maybe I just want to, because in that case, I would prefer probably just to raise the volume by raising my hand. But I know that raising my hand in front of the camera, the webcam of my laptop is not very well working. So maybe I'll probably do this. Or if you remember the 3D touchpad I've just showed in the beginning, and they had a clockwise or counterclockwise circle in order to increase or decrease the volume. So the question is transferability raises the question whether I would be able to reuse or maybe to redefine the gesture for the same action in another context of use. And maybe with another device.
Exactly.
If I have a leap motion and a Kinect, would I use the same gesture for performing the same action? In principle, yes. But I'm not sure that the recognition rate or the recognition engine behind will be the same or will be efficient enough. But that's a technical question, of course, and that's another thing. Well, Well, thank you very much for all this question. I think that the discussion was even more interesting than the presentation.
No, don't say that.
No, I think it was very good to have first the presentation and then also some very interesting discussion. Now I think that was a perfect combination, I would say.
Yeah. Thank you.
Okay.
Do we stop here?
Yeah.
What do you think? I think we already spent 2.5 hours. Are there any other comments or questions? Otherwise, we can maybe round it up here indeed, yeah. And then I think it's already next Tuesday, right, when we have the next presentation. So then I think it will already showed us some teasers, so we know already a little bit where to go. And yeah, let's spread the word. I mean, maybe some others are also still interested. I will also send a new reminder out. And I hope to see some of you then also next week again when Jean will give us some more insights and we have maybe another interesting discussion after his presentation.
Yes.
Thanks a lot, Jean. Very interesting. And
thank you very much to everything. Thanks for participating and especially for your question, because the better the questions are, the better the answers are.
Thank you.
Thank you.
It was very fun. Thank you. See you soon. See you. Bye.
See you. Bye-bye.
Bye.
See you. Bye.
Thanks a lot.